I wrote this out in the notes box for the activity today, but uh, it may seem like we're moving super fast through this and just like kind of bouncing from topic to topic. It would be more clear how everything fit together if we were in school. So I apologize if it does seem like that to you. You're not wrong. And we are kind of bouncing around. Modeling with geometry includes a lot of different things. So I'm sorry about that. Maybe. But yeah, so anyways, so we're starting off today by talking about volume of different objects. So basically we're going to do this by doing a ton of examples. I'm sorry that I'm just like messing around with everything while I'm talking. Okay, so we're going to start off with the sphere. So this says a sphere has diameter of 4. Okay, and in our equation for the volume of a sphere, we have 4/3 pi r cubed. Okay, so now they give us a diameter, but this volume equation is in terms of r, and r is our radius. Okay, so we would prefer to have all of our units in terms of the radius so that we can calculate this. So we're going to say the radius is equal to 2 feet. Okay, so the diameter was 4. Remember, the radius is half of our diameter, so our radius is 2. It says find volume in terms of pi. This means that you can leave pi in your final answer. So I'm going to have that our volume is equal to 4/3 pi times 2 cubed. Now 2 cubed is 8, and 8 times 4 should give me 32/3. Oh my goodness, my screen is going so slow. I'm sorry, my computer is not happy today. And then we have multiplied that by pi as well. And since we cubed our radius, which was in the feet unit, our final units are going to be feet cubed. Okay, so let's see. Yep, so that would be the final answer for this problem. And remember that a sphere is like a perfectly round ball, kind of like this, where your radius, oh, I overdrew my radius, is from the center to any of the outer edges. Okay, and your diameter, remember, is all the way across. So our diameter, D, would go all the way across our sphere. Okay, then it says find the volume to the nearest cubic foot. Okay, so now we actually have to multiply all this out. So you can grab your calculator, and we will have 32 divided by 3, and then we will multiply by pi, and click enter, and we get 33.51. Now it wants us to do this to the nearest cubic foot. So we have 33.51 feet cubed. Okay, but the nearest foot is this place right here. So I need to take my digit that's right after the place that I want, and I need to round the next place up. So that 5 rounds that 3 up to a 4. So my final answer will be 34 feet cubed. Okay. All right, so that's the sphere. The next thing we have is a right cylinder, and it has a base radius of 24.1 centimeters. This is a key thing. And then the height of 17.3 centimeters. Okay, so let's draw out what this would look like. It's nicest to be able to visualize the things that we're working with when we're thinking of volume so that we can like have an idea of what we're doing. So it says that our radius is, also I drew this not to scale because 24.1 centimeters is much larger than the height, which is 17.3. So this should really be like a short and fat cylinder. But that is not how I happen to draw it. I'm very sorry. Okay, so now it first says express the volume of the cylinder in terms of pi. The volume of a cylinder. I like to think of this one more logically as opposed to memorizing it. Now you have these circles, and remember the area of a circle is pi r squared. Okay, so I have that circle, and then I'm taking that circle and I'm stacking it up as many times as I have the height. So then I need to multiply by my height. Okay, so the volume of your cylinder is going to be pi r squared h. Okay, so that's another one of our key equations. In this particular example, our radius was 24.1 and our height was 17.3. So if we fill these values in, we should get pi times 24.1 squared times 17.3, and this should give us 10,048.01 pi centimeters cubed. Okay, this is our final answer. It said in terms of pi, so I've got my pi in there, just like I did before. All right, this is our cylinder. Okay. Then part B says find the volume to the nearest 100 cubic centimeters. So here I need to actually multiply out what I had in the first part. So 10,048.01 times pi is going to give me 31,566.7544 centimeters cubed. But this says I want to the nearest 100 cubic centimeters. So I want to go to the hundreds place, draw my little line, and I need to use the digit before the hundreds place to round the hundreds place up. So our final answer here should be the 6 rounds up the 5, so 316. And then we need zeros as our placeholders for the other digits, and then centimeters cubed, right? Because we don't want it to go we don't want it to go down. We're rounding up. It's not 316. I have to have these zeros and replace the digits that I used to round up with. Okay, so this would be my final answer for this part. Okay, I'm very sorry for the lag on this video. Okay, next we have a cone, and it has a radius of 7 inches. Okay, so let's draw out a cone. Okay, we've got our little cone, our little party hat. Okay, and it's got a radius of 7 inches. So that means that this guy right here, radius 7 inches, and a height of 5 inches. So from here, again, this should be short and fat. And I drew it tall and skinny. I'm sorry. The height is 5 inches. Okay. Now, volume of a cone is 1/3 pi r squared h. So it's kind of similar to the cylinder, except it's multiplied by a factor of a third because you're shaving off these pieces here. And there's a mathematical way to show how to get that, but we're not going to go into that detail right now. So this is the volume for a cone that you will need to remember. So first it wants us to just find the volume of the cone in terms of pi. So we're just going to sub in all the values that we were given. So radius is 7. We are squaring that. And then we have height, which is 5, multiplying that in. Now 7 squared is 49, and 49 times 5 is almost 50 times 5, which would be 250. And then I need to subtract, so 245. Let's double check it. So 49 times 5, 245, sweet. And then we divide that by 3. So